So hello everybody, welcome to my presentation. Today we're going to be looking at LLM powered dashboard. So the title is quite long, but what it really means is using LLMs to create Neo4j dashboards with human readable text. And we're going to be using NeoDash for that. So there will be a quick intro, then a bit of a demo, and hope to squeeze that into half an hour. Right, so who am I? So my name is Niels. I work for Neo4j now for almost 4 years, working in the professional services team. And what my team does is we build full stack Neo4j applications. So we help our customers go from their very first prototype to a completely production ready system. And this could involve many things, and visualization is one of them. And that's the reason why I'm involved with NeoDash. So this is a project. NeoDash is a project that we've been working on for almost 3 years now, and it's been a really nice journey to work on a visualization tool and kind of help out the people that use Neo4j to make their graph visible. This has been a big team working on this. It's an open source project, but I just wanted to give a shout out to the other core contributors here. So you see their pictures on the screen. Jacob, Bastian, Marius, Alex, Alfredo, and Harold. Thanks a lot for all your work. It's been really fun working with you on this one. Good. So jumping right into it. So I don't want to go very deep into NeoDash today because the focus is really on these LLM powered queries. But just to give you an idea, if you haven't heard of NeoDash before, it's a dashboard builder for Neo4j. And what does that mean? It gives you a tool to very, very quickly build a dashboard with graph visualizations, tables, bar charts, maps, all kinds of visualizations on top of a Neo4j database. So what we often see working with Neo4j is that you want to visualize your data as a graph because you're obviously using a graph database. But a graph is not always the only visualization you need. You might need to have a table next to it, or bar chart, or other things. And visualizing a graph is much more than just a graph visualization. It's having all these things together, interlinked to create this kind of nice demo. And I've got a screenshot here with all the kind of stuff you can do. Good to know about NeoDash is that it's a Neo4j Labs project, which is kind of the incubator for new tooling in Neo4j, which means that it's open source, but there's no support like we have with our product supported features. It's free to use, but yeah, open source and yeah, community, a real community project. I think that's the best way to put it. Good. So NeoDash, what can you do with it? As I said, you can create an interactive dashboard with visualizations, but it's also an extendable tool, which means that you can add in your own plugins or other people's plugins and make it a more powerful dashboard. So some of the stuff that you can do, you can add in your own custom visualizations. You can add in custom logic, which is the interactivity that I talked about earlier, or even like custom styling and this rule-based styling that you have in Bloom as well. But today I want to talk about the fourth official plugin that we've written for NeoDash, which is the text to Cypher translator. And this is where the LLMs come into play. This has been a lot of work. And again, this was mainly the brainchild of Alfredo and Alex, who you saw in the slide earlier. So thanks again, Alfredo and Alex, for letting me be the one who presents here. But it's been a lot of work from the two of you. Text to Cypher, yeah. So what does that mean? I call it a translation. It's really a translation of a human question, a natural language question, into a Cypher query. So you can imagine a graph with movies and people, and you can write a question in English. Show me all the movies in which Tom Hanks played, and then using an LLM to convert that question into a Cypher query. Now, this sounds like magic, and it is very close to magic. I don't know if it's a science, but it's more of an art. And there has been a lot of really nice work done on this. So these are just some of the blog posts that you can find on the Neo4j developer blog. The work by Thomas is absolutely amazing. If you're interested in using LLMs for this kind of stuff, highly recommend to check it out. So we've honestly learned a lot from these and based many of the work that we did in NeoDash based on the work from others. So what does it look like? This is the UI in NeoDash, and you will see this in the demo later. And it's really quite simple from a UI perspective. You have a box in which you can write a question. in this case, a graph of all people who acted in the matrix, similar to what I just said, right? This is a human readable question. Then the LLM using some smart prompt engineering, can convert that for you into a Cypher query. So completely valid Cypher query using the labels and the relationships in your graph and the properties of the nodes. And then finally, directly visualizing that in a tile on the dashboard. So it could be, again, as I said, a graph or a table or whatever. But it's really quite a simple process, and you'll see this. You can very quickly start prototyping these dashboards with these queries. Now, the traditional way to use NeoDash was always to use Cypher, but this is just an extra step or an extra feature that you can do before writing the Cypher, converting that into a Cypher query with natural text. And I said there's some prompt engineering tricks going on under the hood. So I just want to very high level talk about what's the magic underneath, the secret sauce in this plugin. And it's really a combination of many things that we feed to this LLM to be able to generate the best possible Cypher. Starting with a task definition. So this is where we say to the LLM, hey, pretend that you're a Cypher expert, generate a Cypher query, blah, 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 blah. We give it the user question, so the text that I just wrote earlier. We give it the database schema, so we tell it these are the labels in your graph, these are the relationships in your graph, these are the properties on the nodes and the edges. So we give that to it as well, so it's able to understand that if I talk about a movie, I'm talking about a movie label in my graph. And then finally, we're also giving that query examples. So we're telling it, for a table, you need to generate a query that looks like this. For a graph, you need to generate a query that looks like that. And really bundling this all up and combining that into this prompt, sending that to the LLM, generates a really nice Cypher query. Good, so now we get to the fun part because we're gonna try this out. So one of the things that I really enjoy in my spare time is cooking. I love playing around with different recipes and trying out different stuff. And I was thinking, what if I can use a graph to help me recommend new recipes that I can try? So I loaded up a data set called Recipe NLG, which is an open data set from Poznan University of Technology. Very cool, 2.2 million recipes and ingredients in them. So we put that in a graph, and now I just want to try, can we use NeoDash with this plugin to create some natural language queries and turn those into Cypher and turn it into a dashboard? Now there's two flavors of what I'm gonna do here. One is the one-shot translations, which is, let's try if we can, in one shot, create a correct Cypher query based on a question. Now you'll see that this is quite hard, but it works for some cases. And then the assisted querying, which is the kind of the step back saying, okay, maybe an LLM cannot provide me with the perfect Cypher query, but can it get me 80% of the way there? Can it do me 80% of the work for me, and I just have to tweak in the end? So if you're familiar with GitHub Copilot in VS Code, this is almost the same, right? You generate a code fragment, you need to do a little bit of tweaking, and then you've got your code written much faster. So more like an assistant rather than a completely independent tool that writes Cypher for you. So I'm gonna jump into the demo now, and I'm gonna open up NeoDash. And yeah, just FYI, NeoDash is a web-based tool. There is a free public deployment here, neodash.graphapp.io, that you can use. You can also run it locally. There's a Docker image. You can run it inside Neo4j desktop. There are many places, many ways to run it, but it's always running in the browser. And I've connected to a database of mine. So this is an Aura instance that I have set up earlier. I already loaded the data, so that's all out of the way. And when you're getting started with NeoDash, you can start adding these reports. So if I click this button here, it's going to give me a card, and this is where I can write my Cypher query. So just to give you an example, if I say, show me all the ingredients, or maybe just like 10 ingredients inside a table. I can run that, and it will read from Neo4j and give me a sample of the ingredients. So brown sugar, milk, all these kind of things. So that's the basics of NeoDash. But with this plugin enabled, it actually gives me an extra feature, which is this button that toggles Cypher to English. I'll show you this in a bit, but I just want to show you also how to set up the plugin for yourself. So when you have NeoDash open, there's an icon here on the top right, a puzzle piece that you can click. And here you can decide which extensions to enable. So here I've already turned on the natural language queries extension, and this is the one that we're going to be using. So you just have to click and toggle the button here. Then once that's turned on, there is a new button on the right here called natural language queries. And this is where I put my credentials for the large language model. So we've got OpenAI here. We also support Azure OpenAI. In the future, we also want to support Google LLM services and other things. But we're working on that. So you put your key in there, you validate that, and if everything is okay, you can choose a model that you want to use to generate the cipher. So we've tried several, and GPT-4 is just really, really good. Well, compared to GPT-3, it's infinitely better at generating good cipher queries. So I recommend, if you're using OpenAI, GPT-4 is a good model to use. It's a little bit slower, it's a little bit more expensive, but it's worth the quality of the queries that you're going to generate. Anyway, that's how you set that up. But now let's try it out, right? Before I try it out, I have to say that large language models are by nature non-deterministic. So sometimes they work really well, sometimes they don't. It's kind of a shot in the dark. So we're going to see if we're lucky today with the demo. But I'm going to just try something, right? So we've got our recipes, we've got our ingredients. Let's try writing, show me all the recipes that contain the word cookies. And we're going to show that in a table. Right, got my question here. I'm going to hit translate, and then under the hood, all this magic is happening, injecting the schema, the prompt engineering, where we're taking care of all of that for you. And waiting a little bit and see if OpenAI wants to give us an answer. Come on. So we are not blessed by the demo gods today. Let me try that just one more time. There we go. Great. So took OpenAI a little while, but it has thought about our question and then converted it to this Cypher query. So what did that create for us? Recipe where the title contains cookies. So this is what I asked, right? All the recipes that have cookies in the title. And then it's returning a bunch of values. So the title of the recipe, the ingredients, the ID, all these kind of things. So OpenAI has decided on its own that these are the properties that it's returning to me. I never asked for these properties, but it just saw that these are on the recipe node and figured maybe I'd be interested in them. So that's also quite interesting. If you're not specific with your questions, it makes up some stuff for you, which can be fun or sometimes can be a little bit annoying. But now we've got some recipes, right? All these recipes that contain cookies, and we immediately see the ingredients, which was a property on them, the ID, and also the steps, which is quite a long string, so it's falling off the table here. But that seems to work. Now I want to try the same thing, but with a graph visualization. So I'm gonna go again to my report, graph, and then write, show me all the recipes that contain the word cookies. Exactly the same question, hit translate and see what happens. Now my assumption here is that the model, because it's aware of the type of visualization that I'm using a graph visualization, I don't want to see properties here. I don't want to see strings. I want to see nodes and relationships. And the model has figured it out, right? I said, show me the recipe that's called cookies. It has also given me the ingredients, even though I didn't ask for that. But that seems to work. It's created a cipher query. It looks good. One thing that models are, the LLM models are not very good at is relationship direction. So you'll see here, it actually says recipe in ingredient. So if you're familiar with Cypher, this is the syntax that we use to specify a relationship. So I'm gonna have to fix this. This is a small mistake that it made because it pointed the in relationship from the recipe to the ingredient and not the other way around. So almost correct. And let's run that and see what happens. So There we go. Right, a very big graph. As I said, 2.2 million recipes, so you can expect a lot of cookie recipes. But it seems to work, right? I've got a lot of recipes here. I can click on one, and we see here that this is one called Mars bar sugar cookies. And all the ingredients are also floating in the graph over here. So that seems to work. Great. So we've done a graph, we've done a table. Let's try something else. So I will try now a pie chart. And I will ask it, show me, well, actually, let's see, top 5 ingredients that are most commonly used. So I'm getting, on purpose, I'm getting more and more vague with my requests, right? I'm asking for top 5 ingredients that are most commonly used. So I'm relying on the model to figure out that usage means that it's in a recipe. So the model is actually quite smart to figure out that by usage, I mean an ingredient that's in a recipe, which is quite fun. So I'm going to click on translate again, and then we'll see if we get a nice result. And okay, what do we get this time? Ingredient in recipe, ingredient name category, value, order by value, limit 5. So that's looking pretty good. And this time it actually did the relationship direction correctly. So this is something that sometimes works, sometimes doesn't. As I said, it's non-deterministic, so we never know what happens. But I can run this now, and it's going to aggregate this information and see which ingredients are most commonly used across the recipe database. And this is flour, butter, eggs, salt, and sugar, which honestly is not very surprising because these are quite common, especially in baking. Great. So I just want to do one more, and I want to see if I can get a more advanced query working as well. So something that is slightly more complicated in terms of graph reversals. And same thing, I'm going to choose a graph type here, and I'm going to ask a graph of 10 recipes that contain both honey and mustard. So right now I'm pushing the model even further because I'm not saying that honey and mustard are ingredients. I'm letting that figure out on its own. I'm going to see if it's smart enough to figure out that these are ingredient nodes by just specifying the name, which is nice. Let's see what happens. Okay, that didn't seem to work, so let's try it one more time. And this is the non-deterministicness that I talked about earlier. Sometimes it's worth just giving it another shot. Okay, interesting. Right, so what is it doing here? It did figure out that I'm talking about ingredients, ingredient 1, ingredient 2, recipe 1 this is inverted again, recipe 1 has ingredient 1, recipe 2 has ingredient 2, where recipe 1 ID is a recipe 2 ID. Okay, that seems unnecessary, but well, whatever, let's see. R1 is recipe, limit 10, return recipe. I think this will work. Let's try. Okay, great. It's actually returning 10 recipes. It's showing the recipes, but it's not really what I want because I'd like to see the ingredients as well. So maybe I will tell it to return all relationships and see if now it's also giving me the ingredient nodes. Okay, let's see. Right. Relationship 1, relationship 2. Almost. Now it's returning the relationships for the ingredients, but it's not returning the ingredients itself. So I'm going to do a little bit of tweaking on my own here and just add these to the statement. And I'm going to fix the directions again. And now I'm going to run this. And now we've got, yeah, this is what I wanted to see. Now we've got the recipes as well as their common ingredients, right? So we've got honey and mustard as the floating connected factor in the middle here. So You'll see for more complex queries, it's working as well. You might need to tweak your question a little bit. You might need to modify the Cypher a little bit, but it's on the way there. It's getting there. And honestly, it still feels like magic even after doing this many times to prepare for today. Going back to the slides, let's see what can we conclude from this, right? LLMs are pretty good at generating Cypher queries, but sometimes they do hallucinate. They don't always provide the exact thing that you're looking for. And we saw that it's struggling with relationship direction. Now, there's actually already a solution for this out. There was a competition a while ago. So this is something that we're going to be improving in the next version of this plugin. For more complex queries, it often provides a template that you have to modify, right? So it's generating the layout of the query, but you might need to tweak a little bit on your own. And the final finding that we found was GPT-4 using more complex, stronger models really increases the accuracy and the quality of the queries. And this will get even better soon, as we will have especially fine-tuned models on Cypher generation, and that will hopefully boost the accuracy of these predictions. So very much. Good, I'm almost out of time, but I just want to show you one little bonus feature, just because it's fun to look at new stuff that we've been doing. So Neo4j released a vector index, which is used for storing embeddings in a graph database. And embeddings are really the building blocks, the language of large language models, right? So what this means is that you can now generate embeddings with a large language model and store them in Neo4j, and then use these embeddings together with your graph to do all kinds of interesting stuff. So what we've done is we've generated recipe embeddings with OpenAI. We stored them on the nodes. We created a vector index on the properties, and then we are using NeoDash right now to build a embedding-powered recipe recommender, which sounds very exciting, but honestly, it's just one Cypher query. So I'm gonna take this Cypher query here, and I'm gonna just put that back into NeoDash. Let me go all the way up and make a new tab. So put that in here. And for those of you that are into Cypher and like to hack around with queries, you can take a look at this query. We'll publish this as well online. I'm basically doing some nice tricks with APOC, calling the vector index, and also using a parameter here. So 8 lines of Cypher. It may look complicated, but it's just a nice trick to get a beautiful visualization here. So I can save this. Then you will see a result. But what we really want to do is we want to parameterize this query. So we want users to choose a recipe and then show similar recipes to what we selected. So I'm going to create a new report here, parameter select, and I'm going to let my users choose a recipe title. Now, here is banana bread selected, but maybe I can choose something else. Let's say carrot cake. Carrot cake. So what's happening here? I'm choosing a parameter in the box on the right. This parameter is used inside my query on the left. Then finding that specific recipe, I'm getting the vector embedding, using the vector index to find similar embeddings, and thus find similar recipes to that recipe as decided by the embedding. So this sounds complicated, and it kind of is, but a lot of work is done by the vector index. Again, the vector index is taking care of finding the similarity based on these embeddings that represent the nodes. So maybe we can try another one. Let's do chicken Alfredo in honor of Alfredo, who made this plugin. Right, so this is a cool one. Chicken Alfredo. So we have chicken Alfredo here, and we have a lot of other recipes which seem to be sharing quite a few ingredients, right? Chicken with white wine sauce, chicken and leeks. Interesting stuff. We're seeing chicken breasts as a common ingredient, which makes sense to all of these recipes. But it is quite nice that it's so quick and easy to do this kind of similarity search with NeoDash and make it interactive. So that was just a little tangent, a little bonus feature here. And again, we're going to be working with this more in the future. But the power of NeoDash really is to make this easy and very quickly make an interactive application, as we've done here. And I think that's where you can also use NeoDash for your own projects. Great, so 5 minutes left. That was it for my presentation. I hope this was interesting. I hope it made sense. If you have any questions, you can reach out to me on my email here. Also put this in the chat, and maybe we have time for a couple of questions. Let's see. Okay, great. Let's see. Questions. In NeoDash, open source LLMs, i.e. LLMs from Hugging Face, will be available in the future. Yeah, exactly. Yeah, that's possible. So we made this interface extendable, so we can add any kind of LLM provider, whether that's your self-hosted one, whether that's one from Azure. So we're really looking to extend this and make it, applicable to any kind of LLMs. Also for people that have security requirements that don't want their data flowing to a cloud provider, for example. Have you also evaluated other vector models or only the one from OpenAI? So we've tried with OpenAI so far. We're expecting that other models might be significantly better, but we haven't tried. So we're still looking to, for example, I think the Google one is next on the agenda. Okay. Why multiple carrot cake nodes? Yeah. Okay. I forgot to explain this. The database has 2.2 million recipes, but they have duplicate names. So one recipe called carrot cake, there might be 10 other recipes also called carrot cake with different ingredients that just have the same name in the database, which is why they're duplicated. So they're actually different recipes. They're just the same name. That's a limitation of the data set. And I see Alex already said it. Thanks, Alex. In GPT-3, the vectors are quite bad for searching. See, blah, blah, blah. Yeah. Okay. Yeah, maybe that's why. Maybe that's the reason why it wasn't working. That's thank you, Moritz. What else? Thank you. Thanks. I watched another session describing a rather complex process to convert natural language queries to Cypher with Cora, Code Llama, fine-tuning metrics. In what you're showing, it seems that GPT does all the work very easily because the queries are not specialized. That's a difficult question, right? I mean, I think one of the things that NeoDash makes it look very simple because it's abstracting all this complex logic away from you, and it's not perfect, right? I've chosen these queries because I know they're likely to succeed. If you start experimenting yourself, you'll see, especially with more complex queries, that you're going to be struggling, and then you're going to need some fine tuning and more complex applications like LangChain. But this is, again, something that we need to look into. This is really an early access thing at the moment. Yeah, I think that's it. Thanks, everybody. Again, if you want to reach out, I'll put my email address in the chat. And hope to see you at another session. Bye-bye.